All right, in this example here, we're going to be looking at the region R. It's a finite region bounded by y equals x, y equals 2x, and y equals 4. So we can go ahead and do a sketch and see what we're looking at. So let's go ahead and put in y equals 4 first, our horizontal line. So that's going to be our cap. Okay. And then we'll put in the identity function, y equals x, and then 2 to the x. So when x is 1, y would be 2. When x is 2, y would be 4. And so there's our second line there. Well, third line, actually. Okay, and this is the region that we're looking at. I'm going to go ahead and copy it so that when we do the rotation about the y-axis, we'll save ourselves a little bit of time. Okay, so for this one, the axis of revolution is the x-axis. So we want to be parallel with, and we want the shells. Parallel with axis of revolution. Okay. So if I draw my representative rectangle there it is. Okay. The right is determined by x equals y. And then we have y equals 2x. So if I solve that for x, that'll be x is equal to y over 2. So x is equal to y over 2 would be the left side. And so the height of this rectangle or shell is going to be y equals y over 2. Y minus y over 2. So that's just going to be y over 2. Okay. Now we're not doing anything too crazy. We're just rotating around the x-axis, and so the average radius, or the distance from the center of our shell here to the axis of revolution is just going to be 5. If I'm right here, this is about 2.5. And so that's the distance here is 2.5, or if you're down here like 0.8, then that distance is 0.8 from the axis of revolution. So that's just simply going to be y. So for the volume, 2 pi integral from c to d, p of y, h of y, dy. So that's going to be 2 pi. Limits of integration are going to be in terms of y. So it's going to be 0 to 4. And it happens to be the same for the x, but that's just the particular region we're looking at. Okay, so our p of y is y, and our h of y is y over 2 dy. Okay, so that's going to be 2 pi, and we have y squared. So let's do the y 1/2, and so y cubed over 3 would be the integral, 0 to 4. So we're going to get pi over 3, and then 4 cubed minus 0 cubed. And so that's going to give us 64 pi thirds. Is that volume if we rotate it around the x-axis, okay? Now, I think I cut it off when I copied this, but they also want us to rotate around the y-axis. So we'd sketch the same, region here. And then, so we want to rotate around the y-axis now, and so we got to be a little bit careful here, because depending on where you're at, your upper function actually changes. Okay, so if you're to the left a little bit, your upper function is y equals 2x. And if you're a little bit further to the right, then it's actually y equals 4. Now, the lower function is always y equals x, the identity. And so we actually change functions at 2, okay? So at 2 is when we change functions. So, we have a region 1, and we have a region 2, okay? So if we look at, the first region 1, your height function is going to be the difference in the upper function, Sorry, we're going to be doing functions of x. The upper function is 2x, and the lower function is going to be x. So the height function is just x. And then p of x, that's just the distance from the axis of revolution. So that's just going to be x, okay? And so, we could say our first volume is 2 pi, and we're going to go from 0 to 2. So from 0 to 2, and p of x is x, h of x is x, dx. So it's going to give us 2 pi. X squared is what that simplifies down to in the integrand. So when we integrate that, that's going to be x cubed over 3. We're going to evaluate that from 0 to 2. So we're going to have 2 pi over 3, and then we have 2 cubed minus 0 cubed. So that's going to give us 8 times 2, so that's going to give us 16 pi over 3, okay? All right, now when we do the second region, we look at the second region there, the upper function is going to be y equals 4, and the lower function is still the same. The lower function is still x, okay? And p of x is still the same. That's still going to describe the distance to the axis of revolution. So the volume for the second piece there is going to be 2 pi, and we're going to be going from 2 to 4. Oops, sorry, I didn't put in the x. I going too fast for my hand here. So we got x, and then 4 minus x dx, okay? So that's going to be 2 pi, integral from 2 to 4, 4x minus x squared dx. So it's going to be 2 pi, and we're going to have 2x squared minus x cubed over 3, and we're going to evaluate that from 2 to 4, okay? So that's going to be 2 pi, and we'll have 2 times 4 squared minus 2 squared, minus 1/3, 4 cubed minus 2 cubed, okay? So that's going to be 2 pi, 2, and that'd be 16 minus 4, that's going to be 12, minus 1/3, and we'd have 64 minus 8, so that's going to be 56, okay? All right, so that's going to give us 2 pi, 24 minus 56 over 3, okay? And 24 would be 72 over 3 minus 56 over 3. So it's going to give us 2 pi times, let's see, the difference there would be 16 thirds. So this would be 32 pi over 3, okay? Now the actual volume is going to be the sum of the two volumes we just found, which is 16 pi over 3 plus 48 pi over 3. And that's going to be equal to, I wrote it down wrong. I was already adding them in my head. 32 pi over 3, pardon me. So 16 pi over 3 and 32 pi over 3. I was just excited to finish it off here. Finish the problem. So 48 pi over 3. So it's going to be 16 pi. Okay. Alrighty. Well, I hope you found this helpful. We'll see you next time.